The moment of a force is the product of the force and the perpendicular distance to the line of action of the force. Moment of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. So we have two diagrams now. The first diagram, we see force acting downwards, and we see the perpendicular distance. So moment is force times perpendicular distance. In the second diagram, the force is acting at an angle theta. But since we are looking for the perpendicular distance or the perpendicular force, the horizontal component of the force or the vertical component of the force here is Fy, and Fy is F sine theta. Fy is F sine theta. So that means the moment now is going to be Fy times d, because that's what is perpendicular. So that will now give us Fd sine theta. So please note that in the two cases. Now here we look at clockwise and anti-clockwise moments. So consider the diagram above. The weight W1 will tend to turn the beam anti-clockwise. You can see the weight here, W1, tends to turn the beam anti-clockwise. Look at the pivot. So the weight is always moving in the direction of the pivot. Pivot can also be called knife edge. Okay, so W2 will tend to turn in the clockwise direction. W2 also will tend to turn in the clockwise direction. Okay, so if the beam is balanced horizontally, it means that the clockwise moment is equal to the anti-clockwise moment. Or let us put it this way: if we are asked to find the clockwise moment is going to be W1 times the perpendicular distance. The perpendicular distance A from W to the point of action of the force. While the anti-clockwise moment will be W2B. That means weight times the perpendicular distance. Okay, that is important. Now, let's look at the condition for equilibrium under the action of parallel coplanar forces. We have two major conditions. There are three, but here we are looking at two of them. Number one is that the sum of the upward forces must be equal to the sum of the downward forces. Or we can say that the algebraic sum of forces in any given direction is 0. Look at this diagram. If I should apply the force in the diagram, you'll notice that R and F3 are moving upwards, F1 and F2 are downwards. So R is the normal reaction, the reaction on the knife edge. Since there are forces resting on the knife edge, it will experience a normal reaction. So we can say that R plus F3 is equal to F1 plus F2. Okay? Now, the second law is that the sum of clockwise moment is equal to the sum of what? Anti-clockwise moment. So, if you look at the diagram clearly, you can see the direction of each of them. R is already on the knife edge, so it doesn't have a moment. R does not have a moment. But look at F1 having a moment. F1 has a moment. This clockwise moment, both F1 and F3 are moving anti-clockwisely. So the moment there will be F1x plus F3. The distance from F3 to the pivot is Z. So that is it for that, the anti-clockwise moment. But F2 is moving clockwisely. So this will be equal to, the moment of F2 will be F2 times the distance is Y. So the distance it makes with the pivot is Y. So we have F1x plus F3z is equal to F2y. Now that is very important. So that's exactly what we have here. According to the condition, the first condition, F1 plus F2 is equal to R plus F3. That means the sum of upward forces is equal to the sum of the downward forces. Now, directing all forces towards the pivot, just like we have in the diagram. The anticlockwise moment is F1x plus F3z, while the clockwise moment is F2y. We've done that. The normal reaction has no moment since it is situated on a pivot around which the rotation occurs. So we've have shown you the relationship, which is that F1x plus F3z will be equal to F2y. Okay, let's proceed. Now look at this question. We are asked to find the normal reaction P plus Q and Q in the figure above. Now before we do that, the first thing is we can use the first law, which is that the sum of upward forces is equal to the sum of downward forces. And if you look at the upward forces, it is P plus Q. The downward forces is 10 plus 40 plus 25. Okay, that's going to give us a total of 75 newtons. That's the first thing. So P plus Q is 75 newtons. Now the second can now help us to find that. Here we are going to take moment about one of the pivots, because moments you must make a point of reference. So we have two references here, A and B. So we are going to work with reference A. So if we are working with reference A, it means that P does not have a moment. Let's direct all the forces towards the pivot P. This one would go this way. This one will go this way. This one will go this way towards P, the pivot. Even Q will go this way. Now that's towards the pivot. Please note that if I pick the pivot B, it means that Q will have no moment. All of them will be directed towards Q. So please note. Now, to take the moment, the force is moving clockwisely is a 40 newtons force and 25 newtons force. Clockwise means in the direction of a clock. So let's see the moment. We are going to have 40 multiplied by the distance between 40 newtons and the pivot is 30 minus 15, which will give us 15. Then plus the 25 newtons force is going to be 25 multiplied by the distance between the 25 newtons and the pivot is 50 minus 15. 50 cm mark minus 15 cm mark. That will give us 35. Okay, equal to, now look at Q is moving anti-clockwisely. So and the mark is 42 minus 15. Look at the diagram. That will give us 27. So we have 27Q. Then plus, look at the 10 newtons force is also moving anti-clockwisely. Then the perpendicular distance is 15 minus 5. That will give us 10. So that will 10 times 10 will give us 100. So 40 times 15 here is 600 plus 25 times 35. Let me do that here quickly. 25 times 35, 875. So this is 875 is equal to 27Q plus 100. Okay, so 600 plus 875 is meant to give us 1475. 1475 is equal to 27Q then plus 100. So with that we can find Q. So Q now, let me do that quickly. Your Q now is 50.92, so approximately 51. So my Q is equal to 51. And if my Q is 51, remember that P plus Q is 75. That means P will be 75 minus 51. And that will give us 24 newtons. So that is the answer for the normal reactions at P and Q. Okay, so let's see what we have here. As I rub this off. So, okay. Yeah. You see that? exactly what I just explained. So you can use this to work, applying the principle of moment. Now, the next is determining the weight of a rod using principle of moment. The weight of a uniform rod is concentrated at the center of the rod. But if the rod is not uniform, the weight is at the center of gravity of the object if the rod is not uniform. So when you say a rod is a uniform rod, let's assume that you have a rod this way. Uniform means that the quantity of matter is evenly distributed. So the weight will definitely be at the center. The weight will be at the center, okay? So if the mark here is 0 and here is 100, it means that the weight is concentrated at 50. Now that is important, okay? Now look at this question. It says, what is the weight of a uniform meter? You see the word uniform there. What is the weight of the uniform meter rule if it balances on a knife edge at the 35 cm mark when a weight of 20 newtons is hung on one of the edges? Okay, let's look at this. This rule is a meter rule, so it's calibrated 0 to 100 centimeter. Okay, and the weight, remember, like I said, is always acting downwards. And the question says that the weight, we are looking for the weight, so W. Now the pivot and the weight must be at the 50 cm mark because it's uniform. Now it says if it balances on a knife edge at the 35 cm mark, this is the knife edge here. At 35 cm mark, which should be before 50, so that means the knife edge is here. When the weight of 20 newtons is hung on one of the edges. Now this is where the 20 newtons weight must hang if this roller must be balanced. You can't put it on the other side of the pivot. It has to be here. It has to be, you can't put it here. That would be wrong because the weight will be too much on one side and it will fall. So for it to balance up, I have to put it on the left hand side. Now, according to the principle of moment, you see that this guy directs all the forces towards the pivot, like this force. Look at this force. If it falls, this is how it falls. So 20 newtons is moving anti-clockwise. W is moving clockwise now. So the anti-clockwise moment now is going to be 20 multiplied by the perpendicular distance is 35 minus 0, that's 35. Then equal to the weight multiplied by the perpendicular distance is 15 minus 35. 50 minus 35, that will give us 15. So that means my W now is going to be 20 multiplied by 35 divided by 15. So let's see that. So 20 times 35 divided by 15. And that will give us 46.67. So the answer is 46.67 newtons. This is beautiful. Okay, I have the solution written here. Let me show you that just to explain further on what I've just done. You see that? Exactly what we just did. And follow the solving. Let's look at another question here. It says, in the diagram above, AB represents a uniform rod of length 1.50 meters, which is in equilibrium on a pivot P. If AP equals to 40 centimeters, calculate the mass of the rod. Now remember, it's a uniform rod, so the length is 1.5. So that means here is 0, while here is 1.5. Okay. Now the weight of this ruler must act, since it's a uniform rod, the weight must act at the center of gravity. The center of gravity will be 0.75. That's 1.5 divided by 2. So it will be somewhere here. So that's the weight. That will be 0.75 mark. Okay. And so if we want to 0.75, okay, AP is given in meters, in centimeters. So let's change it. That means the whole length here, we're going to make it, instead of 1.5 meters, we'll make it 150 centimeter. Making here 75 centimeter when you divide. Okay, that's important. So let's see. Direct all of them towards the pivot. This is the 7 newtons. This is the weight. Okay, so 7 newtons multiplied by the perpendicular distance of 7 newtons from the diagram is already 40 centimeter, equal to the weight times the perpendicular distance of the weight is P is 40. So 75 minus 40, that will give us 35. Okay, so that means your weight now will be 7 times 40 divided by 35. So let's see what we have here. We're going to have 7 multiplied by 40 divided by 35. So that's giving us 8. So the answer here is 8 newtons. And 8 newtons means 0.8 kilograms. So the answer is D. Okay, so let's see. Now look at another question here. It says the figure above shows a uniform load of weight 200 newtons, that's the weight, and length 50 meters. Remember, it is uniform, so that weight is acting at the center of gravity. It is suspended at one end and suspended by a cord at the other end at an angle of 30 degrees to the wood. Calculate the tension on the cord if the wood is horizontal. This is the tension on the cord. Now let's first of all direct all the forces towards the pivot, like here. Look at this, towards the pivot. Here, this is it, towards the pivot. So the clockwise moment now, 200 newton is moving in clockwise moment. The tension is moving in anti-clockwise moment. So let's see, the 200 newton, the moment is the weight, so is definitely the length of the rod is 50. So that means the weight is concentrated on the 25 cm mark. So we are going to say 200 multiplied by 25 because that's the perpendicular distance to the pivot. Equal to, for T is going to be T sine 30 multiplied by the perpendicular distance from here to the pivot is 50, the length of the row. So with this, we're going to have 5,000 equal to 50 sine 30 is 25, so 25T. So T now will be 5,000 divided by 25. That will give us 200 newtons. Quite easy. Now look at another question here. It says a meter roll is pivoted at its midpoint with a vertical force of 10 newtons hanging from a distance 30 centimeters from the midpoint. At what distance must a 15 newton force hang to balance the roller? Let's read that again. A meter rule is pivoted at its midpoint. So this is the meter rule. Remember, the calibration is 0 to 100. Let me make that better. So we have 0, we have 100. It's pivoted at the midpoint. The midpoint is obviously 50. With a vertical force of 10 newtons hanging from a distance of 30 centimeters from the midpoint. So let me make the 30 centimeters here. Okay, that is 10 newtons. But the distance here is 30 centimeters. Now remember that if this is 30 centimeters, that means this is resting on the 20 cm mark. I'm making it, 30, that's 50 minus that. Now, from the midpoint, at what distance must a 15 newtons force hang to balance the meter roll? That means the 15 newtons force must hang somewhere here. This is 15 newtons. So we can call this 15 newtons. We can call this x. So if we direct all towards the pivot, we have this and we have this. So we are going to have 10 times 30 is equal to, we are going to have 15x. Because 10, 30 and 15x. So that means my x now is going to be 10 times 30 divided by 15, and that will give me 20 centimeter. But that is the distance. The question is, what distance must a 5 Newton force hang balance on the ruler? Okay, and the answer is 20. That means it must be placed 20 centimeter from the pivot. So C is the answer. Beautiful. Look at this. It says a uniform beam HK of length 10 meters and weight 200 newtons is supported at both ends as shown above. Okay, a man weighing 1000 newtons stands at P on the beam. If the reactions at points H and K are 800 newtons and 400 newtons, then the distance HP is, okay, first of all, the man stands here. Okay, let's do that again here. We have H here, we have K here. Both have a normal reaction. One is 800, the other one is 400. A man is standing somewhere here. At point P, 1000 newtons. The weight of the ruler is somewhere here, which is 200 newtons. Okay, and remember the weight is always at the center. So if the length of the rod is 10 meters, that means this weight here is 5. Okay, then the point P is not given. I guess that's what we are asked to find, the distance H P. Okay, so let's first of all see, we say that sum of upward forces must be equal to sum of downward forces, and this is correct because the upward forces here is 800 plus 400, which is 1200. The downward forces is 1000 plus 200, which is 1200. So that is correct according to the principle of moment. Now, but if we must continue, I'm going to call, let me call here X cm mark. Okay, X cm mark, and let's take the moment about H. Let's direct all towards H. This is H here. So that means this will go this way, this will go this way, and this will go this way. So we are going to have 400 times the perpendicular distance of the 400 Newton and H and the pivot is the whole length of the meter rule, which is 10. That will give us 4000. That's for the anti-clockwise moment. Now, but the 1000 newtons and the 200 newtons are moving in clockwise moment. So we are going to have clockwise moment 1000 newtons multiplied by the perpendicular distance from 1000 newtons to that. We say it's x. We don't know what it is. It's x. Of course, x minus 0 actually, because it starts with 0. Then plus the weight is 200 newtons, so 200 times 5. 5 is the distance, so we're going to have 1000x plus 200 times 5 will also give us 1000. So I'm going to have 4000 being equal to 1000x plus 1000, which when we solve, we see that our x is going to give us 3 meters. That's the answer. So C here is the answer. Another question here. A uniform beam PQ of mass 20 kg and length 5 meters is balanced as shown above. A man of weight 800 newtons stands at M. Okay, that's the mass 800 newtons, such that QM is 2 meters as shown in the diagram. The reaction at P and Q respectively are. Now in this case here, the weight acting downwards That's 800 newtons. This is the reaction at P and Q here and here. And the weight of the ruler is 20 kilogram. 20 kilogram means 200 newtons, so it must be at the center. Okay, this is the center here. The center here means that the mark will be 2.5. Okay, so we have 200 newtons as the weight. So according to the first law, we know that P plus Q, the reactions P plus Q is equal to 200 plus 800. Sum of upward forces must be equal to sum of downward forces. That will give us 1000. But that will not solve it. We can now take moments about either point P or point Q. So let's take moment about point P. It means direct all of them towards point P. Look at point Q. So we are going to have for 200 newtons force, the moment is 200 times 2.5. The distance is 2.5 from the pivot. Now plus the 800 newtons force is 800 times the distance from the 800 newtons to P is okay, you can see that from the 800 newtons to Q is 2 meters, so that means to P will be 3. So we are going to make it 3. So this is going to give us 500 plus this is 2400. That will give us 2900. Okay, that's the clockwise moment. Now, but Q, if I direct Q, is going to be Q multiplied by 5. Okay, Q multiplied by 5 equal to 2900. Clockwise equal to anticlockwise. That means Q now will be 2900 divided by 5. If we do that, we are going to get 580. So that means Q is equal to 580. If Q is 580 newtons, then it means that my P will be 420 because they both sum to give 1000. So the answer P and Q, P is 420, Q is 580. So the answer to this question is B. This is beautiful. Okay, so